Hi, my name is Helena Sheehan and I'm vodcasting for biolog.ie, and I am going to do a vodcast on the breathing mechanism. So you need to know the structure and the function of the lungs. I'm not going to go through the structure of it right now, but I'm going to go through exactly what process occurs when we breathe in, when we inspire, and when we breathe out, when we expire. So a quick diagram of the lungs here. We've got the nasal cavity coming down into the larynx, which is the voice box, the trachea, which branches out into the bronchi, and then you have the lungs. Okay. Now what's very important in the breathing mechanism is the muscles. So there are muscles that control breathing, and here we have the diaphragm. So that's very important. And then along here we've got the intercostal muscles. Okay. So here's our diagram of the lungs with the diaphragm, got our label. It's very important to label your diagrams. I am going to only label the muscles in this case, because that is what is important. The intercostal muscles. So let me just explain when a muscle contracts. So if we take the diaphragm, so the diaphragm is curved underneath the lungs, and it separates your thoracic cavity, your chest cavity above, and your gut or your abdominal cavity below. So here we have the diaphragm. Now the diaphragm is a broad sheet of muscle under the lungs, and when it contracts it means it gets shorter, so it flattens out. So here is a contracted diaphragm. And here is a relaxed diaphragm. So as you can see, the contracted diaphragm, the straight line here, it is shorter than the relaxed diaphragm. So let's see what happens to the lungs when the diaphragm contracts. So I'm going to explain breathing in, inspiring. So what happens, and I'm going to do it in a different colour. So what happens here is the diaphragm contracts, and when the diaphragm contracts, it straightens out. And the same with the intercostal muscles, they contract. So this is the first thing that happens when we breathe in. The diaphragm and the intercostal muscles contract. Now we often think that if the diaphragm and intercostal muscles contract, we think then that the lungs get smaller, because contract means to get shorter. But actually the opposite occurs, because as you can see, if we draw the lungs, when the diaphragm and intercostal muscles contract, the lungs actually expand. So they pull the lungs down and out upon contraction. So the red here shows contracted muscles. C, that should be a C. So the red is the contracted muscles, and the black is the relaxed muscles. Okay, so the first thing that happens when we breathe in, the diaphragm and the intercostal muscles contract. That means they get shorter, and as a result the lungs are pulled down and out. Therefore the volume of the lungs increases. The lungs expand and the volume of the lungs increases. Now this means that any gas inside of the lungs is now under a lower pressure than it was before. So that's another thing I need to explain. A gas under a low pressure and a gas under a high pressure. If we take, say, okay, so here we have a container, and this is something you did in junior cert. So here's a container and it's got some gas particles in it. Now if we enlarge that container and it's got the same amount of gas in it, the gas has more space. Okay, therefore, in this container, the gas is under high pressure. And in this container, the gas is under lower pressure. So this is an important concept for the breathing mechanism. A gas under high pressure. High pressure means the gas particles are squashed together, whereas here they've got more space, they're after moving out, the gas is under low pressure. And the next thing is a gas will always fill its container. Therefore, if you make the container bigger, the gas will spread out and it will fill that container. It won't all stay in one corner over here, it will spread out. So the gas will always fill its container, and therefore it will be under a lower pressure here. So if you think of, say, a balloon, when you blow air into a balloon, you're literally squashing all that air into a balloon. So the air in the balloon would be under high pressure. So if you've got a balloon, the air in the balloon is under high pressure. Now if you open that balloon, you know that immediately the gas is going to come out and the balloon is going to deflate. And the reason is, when you open the balloon, you've given the gas the option of filling a larger container, that is a room. And the gas will choose to expand and to fill the room rather than the balloon, because it will always go, this is the next thing, from high pressure to low pressure. So a gas will always move from high pressure to low pressure if given the opportunity. Okay, so a gas under high pressure here, it's squashed into this container. Here we enlarge the container, the gas spreads out, it fills the container, and now it's under lower pressure. So a gas will always fill its container and it will always move from high to low pressure, as in the case of the balloon that you open. So if we go back to the lungs, so what happens? There's gas, there is air inside in the lungs. And when the diaphragm and intercostal muscles contract, the lungs expand. So now the air, or the gas inside in the lungs, has got more space. And therefore it is now under a lower pressure than it was previously. So we've got now low pressure inside in the lungs and a higher pressure outside in the air. And as I mentioned, a gas will always go from high pressure to low pressure, and therefore we breathe in. So that is inspiration. Okay, so just to repeat that one more time. When we breathe in, the diaphragm and the intercostal muscles contract, that means they get shorter. Therefore, the lungs expand. Now the air inside in the lungs has now got more space, so it's under lower pressure than the air outside. And a gas will always go from high pressure to low pressure, and therefore we breathe in. And when they ask this in the exam, they tend to say, explain the breathing mechanism, and in your answer refer to the volume of the lungs and the pressure of the air. So you do need to mention those two things. When we expire, which is what I've got drawn in black, expiration, the diaphragm and the intercostals relax. So the diaphragm here is relaxed again, as are the intercostals, and therefore the lungs get smaller. Now if the lungs get smaller, that means there is less space inside in those lungs again for the air within it. So now the air it's getting squashed really. So the air now is going to be under high pressure. And the air in the lungs then is under a higher pressure than the air outside. And therefore the air goes from high pressure to low pressure, so we breathe out. And that's the breathing mechanism.